So now we've got this idea about equations being equal and balancing both sides. Let's take a look at some strategies for how we actually end up solving these. Because sometimes with algebra, with the easy equations, you can just do it from intuition. Like you'll look at it and you'll know, oh, I know exactly what that is. But let's look at developing the skills on the basic equations so when we get to the hard ones, we don't have any issues. So looking at one-step equations, I want you to think about opposites, where plussing and minusing are opposites and timesing and dividing are opposites as well. So the first thing we're going to do is think about what the equation says in words for us. So if I look at the first one, it says x plus 4 is equal to 9. So something I don't know plus 4 is equal to 9. And a couple of you will think, oh, I know the answer. But let's again work on showing the skills for how do I do that. And the aim here, if I want to say it, aim is to get x by itself. So think of x being a loner little character and it wants to be by itself. And currently x is sharing this side of the equation with a plus 4. So if I'm going to think about getting x by itself, I have to think about how do I move a plus 4. And what we're going to do is we're going to show our working by saying, well, what happens if I take away 4 on this side and I take away 4 on that side? So if I minus 4 blocks from one side of the equation and I minus 4 from the other side of the equation, I've done the same thing to both sides. But what's plus 4 minus 4? That's equal to 0, which is how I get the 4 to go away. And what's 9 minus 4? That's 5. So I've taken both sides of this equation, if you want to imagine it was x, and 4 little blocks of 1 on one side, and it was 9 little blocks on the other side. And if I take 4 off of here, and I take 4 off of here, I've done the same thing to both sides of the equation, and I've got 5 left. So that's basically what we're trying to show. How do I move to get x totally by itself? And one way I can do that is by canceling out the plus 4 by using the opposite, which is minus 4, so that makes it go away. Let's look at the next example. In this case, we have in words 5x, which is really saying 5 times x is equal to 15. So what's the opposite of times? You should be thinking that that's divide. And currently x is stuck to that side of the equation with a times by 5. So if I want to get x by itself, I need to think about what's the opposite of times by 5. And that is in fact divide by 5. So there's a couple ways you can write this for working. We could write a divide by 5 is equal to 15 divided by 5. Oops. Where again I'm putting divide by 5 on both sides because I have to do it to both sides of the equation. So what's 5 divided by 5? That's 1. So I'm left with just the x. And what's 15 divided by 5? That's 3. And that's my answer. But another way to show our working for this, which is often how I do things, is remembering that fractions and dividing are kind of the same thing. So for me, visually, I like this one better. If I'm going to divide both sides by 5, I show them as a fraction. And now I can see what's 5 divided by 5. Well, those cancel. I'm left with the x. And 15 divided by 5 is 3. So I get to my answer, x is equal to 3. So again, here it said 5 times x, and I'm thinking, what's the opposite of times? Oh, that's divide, so I'm going to divide both sides by 5. Let's look at 2 more examples. Again, if you want to think about pausing this and trying them on your own, then watch to see if you've got them right. So this first equation, a, something I don't know, a minus 3 is equal to 10. So if I want to get a by itself, currently it's got a minus 3 on the same side with it, so the opposite of minus 3 is going to be plus 3. And so to show that, I'll do a plus 3 on both sides, because minus 3 plus 3 cancel each other out, they go to 0. So I'm left with just the a, and 10 plus 3 is 13. So that's my working, showing that I'm adding 3 to both sides to make it happen. Looking at the next example, in words again, sometimes it helps to figure that out. This is saying x over 6 is equal to 5. Well, x over 6 is the same thing as saying x divided by 6. So what's the opposite of dividing by 6? That's going to be timesing by 6. And I can show that by saying times by 6 on both sides of the equation. In this case, I see that timesing by 6 and dividing by 6 are opposites. You kind of get a fraction that would look like this if you were to rewrite it. So 6 over 6 is equal to just the x, and 5 times 6 is equal to 30. So my final answer is x is equal to 30. So it's really important, even though a lot of the time on these you might be able to look at it and know what the answer should be, I really want you to focus on trying to show you're working for this. Developing those skills that to get 5x, to remove the 5 so you get x by itself, you have to divide, you have to do the opposite of timesing by 5. So focus on trying to show at least one step of your working for these and getting to your answer.